Hello friends, today we are going to talk about units. But before going into that, let me tell you about something which is known as physical quantities. Now, what are physical quantities? So, any quantity which I can measure is known as physical quantity. So, are there any quantities which cannot be measured? And what do I mean when I say that any quantity which can be measured? That means if I have, suppose, a wire and I can measure its length from here to here, no? And I can say it's 25, suppose, centimeters. That means this is my length is a physical quantity because length can be measured. Same goes for mass. I can put this wire on a weighing machine and tell that how much does this wire weighs, and that will be another of my physical quantity. That means it's mass. So from now on, whenever you talk about any physical quantities, if you write a physical quantity, no matter what it is, you have to think about that how can I measure it. You have to find out the way to measure it, and then only you can say that it is a physical quantity. Now, are there any other quantities which cannot be measured but still exist? So, if you think about it, the love you have for your parents or your brother, it cannot be quantified. You cannot say that I love my brother 25 units and I love my mother 30 units. This is not how it works. And similarly, it goes not only for love, it goes for friendship, it goes for human emotions, it goes for bravery, it goes for so many other things which we keep saying that someone is more brave, okay, he's braver than him. But you cannot quantify that. You cannot write the magnitude in front of that bravery or that freedomism or love or friendship. And these quantities are not, then these quantities are not physical quantities because I cannot quantify them, I cannot measure them. And physics and science is generally considered itself with things which can be measured, which can be quantified, which we can say for sure. If this is 25 centimeter for me, this is 25 centimeter for every other person in the universe. So now that we are clear about what physical quantities are, let's talk about some other things. If I can measure it, it's a physical quantity. Now let's see that what are the quantities which I can measure. There's mass. I can say, okay, this, I can take any body and put it on the weight. And I can say, okay, this is how much it weighs. There's length. There's time. You can see your clock and you can define that, okay, how much seconds have been passed. There's energy, there's force. There are infinitely many quantities. And if I have an infinitely long system, it becomes really tough for me. Now, I'm going to tell you about two different things here. One is that if I tell you that you can take a certain number of quantities from this infinitely large set of quantities and place it here under, say, some set A, and if I say that all the other quantities, all the remaining quantities, you put it inside a set B, these are two different sets. The quantities which are in set B can easily be represented with the help of quantities in set A. For instance, suppose you have force in set B. So you can write force is equal to mass into acceleration. Now you can write acceleration as length per unit time square. That means your force can simply be written in terms of mass, length and time. Your acceleration can simply be written in terms of length and time. That means I can have two different sets in which I'll write the quantities in set A, and if I measure the quantities in set A, I can simply tell any quantity in set B just by measuring these quantities. So you don't have to explicitly measure these quantities, although you can measure these quantities explicitly, but you don't need to do it. So the quantities which you actually always need to measure are known as fundamental quantities. These are the quantities which you will have to measure. And these are the quantities which you don't really require to measure. You can, if you can measure this, you can already simply reach from there to there. And that's why these are known as derived quantities, because they are derived from the fundamental ones. They come from the fundamental ones. Force comes from mass, length and time. Now, which quantities will be fundamental and which will be derived? Who will decide that this is a fundamental quantity and this is a derived quantity? See, here I am saying that force can be derived with the help of mass, length and time. But I can also say in other words, that mass can be derived from force, time and length. So which one is fundamental? Is it force or is it mass? Which one is going to be my fundamental quantity? So to answer the same question, a team of scientists sat in Geneva and they wanted to decide that what will be my fundamental quantities and what will be my derived quantities. And honestly, if you really want, if you really want to define another system of yours, you can have whatever fundamental quantities you want. You just need to make sure that all these fundamental quantities, that this set suffices enough that first of all, these quantities needs to be independent of each other. Because if I say force and mass both simultaneously cannot be the fundamental quantity, one of them can be. So these quantities have to be independent of each other. The second thing is that these quantities, with the help of only these, so this set should contain minimum number of quantities which can define every other quantity in the universe. And if you can find that set out of this infinity, you can say that that is my fundamental quantities and this is the fundamental quantities I work with. But to have a very universal convention, people sat around and they went through all these quantities and they found one such set. There can be many other sets, you see. But they found one such set and they called them fundamental quantities. They found 7 quantities, which was the number, 7 quantities out of this infinite pool, 7 quantities, which can define all the remaining quantities in the universe. So you see, these 7 fundamental quantities. So what were these 7 fundamental quantities? So the 7 fundamental quantities which were defined in that convention were mass, that means the matter in any body's object, length, time, current, temperature, I hope you know about all these things, mole, which is known as the number of things in a substance, and then there was luminous intensity. And what is luminous intensity? Well, this is something which you will study further, but just to get a grasp of it, it is something which defines that how bright the light is. Whenever you see a light from tube light, it is something to do with the brightness of that light, and this is something which you are going to study about in your future classes. Now, we have had these things, we have these fundamental quantities, we have these derived quantities. The other conundrum which we face here is that suppose I have a ball, okay. Now you say that the ball has a mass of 25 something and the ball has a weight of 30 something. Now this 25 and this 30 is incomparable. Although it seems that the 30 is greater than this 25, but this 30 is the unit of mass and this 25 is the unit of length, and length and mass has nothing to do with each other. Okay. So how will I differentiate? I cannot simply say that this is 30 mass and this is 25 length, or I can say maybe that. But to define any physical quantities, we need 2 things to measure these physical quantities. We need 2 things. First, you need to define the magnitude of physical quantities, and second, with magnitude, you also have to go for its unit. The unit helps you identify. Why do we need units? We need unit because units helps us identify that whether this thing is talking about mass or whether this thing is talking about length. Okay, so now you understood that what units are. Units are something which says that okay, if this is 30 units of mass, that means there is a very small ball which is a 1 unit of mass, and this ball's weight is equal to 30 of these small balls, and that's how we define 1 unit to 30 units. And that's how you actually are able to understand that how do we define, why do we need units. Now let's come to another point which is kind of an important point, that if you have, suppose, a merchant in old days, suppose in London and in Delhi, they were not connected. There was no idea that there is some, like in really old times, people didn't know that whether London even existed or Delhi even existed. So people in London had no idea about Delhi, people in Delhi had no idea about London. That means, but measurement was still there. People were still measuring weights, people were still selling golds, and for that purpose, they said that okay, I'll have this ball and I'll call this my 1 unit. And in London, people had this another ball and they called this their 1 unit. So it was 1 unit for them and it was 1 unit for us. Now suppose after some time people started visiting each places. People went from London to Delhi and Delhi to London. And in that passage, a merchant came and he bought 5 units of gold here. 5 units of gold from India. And when he went back and he tried selling this 5 units of gold, he found out that actually this was not 5 units, this was less than 5 units. And he was very infuriated because he paid money to buy 5 units of gold. And he ended up buying something which was less than 5 units of gold from London standards. He was very infuriated. And he said that, okay, people in India are cheats, they rob you and all those things. But he was actually, nobody was wrong in this situation, not even the merchant, not London, not Delhi. The problem was that the units were not concordant with each other. They were not concurring with each other. They were not, this mass and this mass was different. So, so after a long time in the same convention, people sat down and said that, okay, rather than having these plethora number of units, I can have a system of units and I can define a very fundamental unit. That means, and I'll call that fundamental unit which will be accessible for all of the world. That means I'll define a ball of mass m, and this will be one unit in both London and Delhi and all across the world. This ball will represent 1 unit of mass. And that is what they called System International of Units, that is SI units. And for mass, the SI unit was kg. For length, the SI unit was meter. For time, it was seconds. For current, it was amperes. For temperature, it was kelvins. For mole, it was N. And for luminous intensity, it was candela. So these are the 7 SI units of 7 masses. And SI unit is an internationally approved unit. That means people acknowledge it all across the world. And those are the units which we call fundamental units. Now, the last part of the video. In this last part, I'm going to talk to you about something known as relationship between units and magnitude. Now, suppose I have, to define any physical quantities, I have magnitude and unit. Now, if I write 2500 grams of something, it comes out to be, it is equivalent to 2.5 kgs, which you guys know that there's, in 1 kg, there are 1000 grams. Now, evidently, if I'll write it in a bit bigger picture, 200 grams, 2500 grams, 2.5 kgs. You see, kg is a bigger unit than gram. That means unit is increasing. Kg is a bigger unit than gram. So, the moment unit increases, you can see and very clearly identify that the magnitude decreases. 2.5 is less than 2500, and it's no rocket science in understanding that. So, you will understand that if I have to, when unit increases, the magnitude decreases. That means in a very short way, you can say that magnitude is basically inversely proportional to units. So that's all for that's all you need to know about units. So let's say what all we have learned. We've learned that there are some quantities which are known as physical quantities, which are derived into 2 parts, fundamental and derived. The physical quantities, if you need to measure any physical quantities, you need to know its magnitude and its units. Now, what are units? Units is something which represent what physical quantity you are talking about. And it is something which helps you measure that thing very easily. Now, once you know the measurement, then we saw the conundrum of the merchant who bought 5 units of gold from India and went and tried to sell it in London, and he thought that he is being cheated, which he actually was not, because the systems were different. There were different units of systems. And then you realize that why SI unit is important. And what is SI unit? SI unit is basically a singular system defined for all across the world, a single standard unit of measurement. And then we saw that there are 7, we saw the fundamental units of all the 7 quantities. And in the end, we learned a very important fact. There is a magnitude of any body is inversely proportional to its units. So if I say 1 gram of something, obviously if I represent it in terms of kg, that 1 will have to decrease. So I hope you guys understood what are physical quantities, and I hope you guys got a crux, got a brief idea about what are units and how we are going to deal with them.